Good afternoon, dear participants of the conference. To your attention, the presentation of the article Research of the Properties of Quarry Tuff for Complex Processing. Let me introduce you to the presentation plan. So, the presentation provides information about description and scope of tuffs, preparation of rock mass for further extraction of useful components by cyclic wetting and drying. The research result is mathematical models of process dependence. Magnetic and spectral analysis of crushed tuff. The research result is establishing the content of magnetic components and the influence of the magnetic field on the quality of their extraction. And conclusions with the main practical achievements of research. Basalt deposits usually contain significant deposits of tuff, which are the products of volcanic eruption. As a mineral, they have already been widely used in agriculture to increase soil fertility and to decontaminate their radioactive contamination as a feed additive for livestock and poultry, as well as building material. In this article, tuffs are considered as a source of valuable metals for industry. The rich mineralogical composition of tuffs, the presence of trace elements of rare metals, high content of iron, titanium, native copper, necessitated their comprehensive processing, the initial stage of which is the preparation of rock mass to extract useful components. Therefore, the purpose of the research was to establish the patterns of softening of perimeter tuffs for extraction and implementation of their magnetic and spectral analysis. In the course of research, it was found that the softening of tuffs is possible with alternate moistening with water and dehydration in a natural way, drying. Based on analysis of experimental data, the logarithmic dependence of the water saturation time on the mass of the sample was established. The figure shows a comparison of experimental data with those held on the basis of a mathematical model which indicated an acceptable latter. To model the process of softening of tuff, it is of considerable interest to determine the analytical type of dependence on which the dehydration process takes place. Initially, it was assumed that the mass dependence of the sample decreases over time during dehydration. Based on this assumption, the following model was obtained, which has a fairly high level of adequacy, but the consistency of experimental and theoretical values in graphical form is not satisfactory, as shown in the figure. Therefore, we calculated a parabolic regression model, which, in contrast to the previous one, takes into account the nonlinear nature of the process. The result is an equation, the determination coefficient of which is higher than in the linear model. The graph of actual and analytical parabolic dependencies is shown in the figure, which shows their consistency. Thus, it can be argued that the process of dehydration is subject to a parabolic model. As a rule, in practice, one cycle of saturation and dehydration is not enough for destruction of tuff in a dump to the conditional sizes. Therefore, we recommend applying a repeated cycle of saturation and subsequent natural dehydration drying. Analysis of data on resaturation of tuff with water and testing on this data of different regression models allowed to choose the most adequate of them. It takes into account not only the influence of time and mass of the sample separately, but also the combined influence of these factors. To illustrate the obtained results, the figure shows the dependence of the mass of tuff on time for 3 samples of different masses. Having determined how and by what dependencies the process of tuff softening takes place, we can move on to the issue of magnetic and spectral analysis of tuffs to determine the particles of silicate and metal parts, as well as the influence of magnetic field strengths on the extraction of magnetically sensitive part and its composition. Previous studies have shown that tuffs contains trace elements of rare metals as barium, manganese, silver, and significant amount of iron, titanium, and native copper. For research, the tuffs of the Raphael basalt quarry were crushed in three groups of size: -2.5, plus 0.63 mm, -0.63 plus 0.1 mm, and -0.1 mm. Next, the weight fraction of each size class in the sample and the percentage of magnetically sensitive part in it was determined and shown in the table. The magnitude of the magnetic field for each sample varied stepwise from 0.08 Tesla to 1.3 Tesla in 5 stages of exposure. Since the third group of size, minus 100 microns, showed complete magnetic immunity, it was attributed to the non-magnetic part of the sample. Based on the obtained results, the magnetically insensitive part of the sample is 49.1%. The different sensitivity of the metallized part of the crushed tuff in relation to the magnitude of the magnetic field induction and size indicates the differences of the trace element composition and the need to bring on preparation to fine grinding without regrinding the product. The nature of the differences of the composition was established by spectral analysis of all obtained fission products. The results of the analysis for sample 1 are presented in the table. It should be noted the lack of accuracy in the percentage of some elements, such as titanium, iron, and the lack of data on the presence of silicates and carbonates in the samples. Their content was determined by chemical analysis. It was precisely established that the iron content in the sample of the first group is 36.2% and in the second 39.6%. Also titanium 1.3% and 4.1%. On the basis of the performed researches, we have established that the degree of grinding of tuff in the process of ore preparation should not be less than 0.05-0.1 mm. The magnetically sensitive part reaches 49% by weight of the sample, and the silicate part is 50-51% at a magnetic field strength of 1.3 Tesla. Therefore, based on the results of experimental and theoretical studies, it was found that tuffs contain valuable elements in the form of native copper, iron, and titanium. Removal of these components is technologically and economically feasible. An analytical dependence of tuff softening by water saturation was established. The saturation time increases with increasing mass of the sample according to the logarithmic law, and the dehydration process occurs according to the parabolic law. The magnetically sensitive part of the tuffs at a magnetic field strength of 1.3 Tesla is up to 50% by weight of the sample, and the rest is the silicate part. Spectral and chemical analysis showed a high content of metals in the magnetically sensitive part of tuff, which consists of iron 35–40%, titanium 2.5–4.0%, and copper in the silicate part 0.4–0.7%. As a result, significant reserves of tuff raw materials in the dumps of basalt quarries are economically attractive for their waste-free use in known areas with the prior removal of valuable components on an industrial scale. Thanks for your attention. You can find more detailed information in our article.